Hello dear students, this is problem number 10 and chapter number 4 of engineering mechanics statics, ninth edition. Okay, so this is our question. This is the loaded truss which is loaded at point C of mass M. Okay, this is the generalized question. So the maximum tensile force which is maximum tensile force limit is 24 and the maximum compressive force limit is 35. It can support 35 kilonewton. This all member can support only tensile force 24 kilonewton and compressive force uh, only 35 kilonewton. So the largest possible mass which may be supported by, we have to find the largest mass which can support uh, one of these member. Okay, so first of all we determine the forces, all the forces is a function of weight, like FAB equal to 5W. So W will then we compare this equation with these limits, tensile force limit and compressive force limit. Okay, like that FAB equal to 5 W. So it is equal to, for example, it is FAB is tensile force, so we equate it with the 24 kilonewton. Okay, then we will solve a mass, what mass can support FAB. Okay, so first of all I take joint C because there is two unknown forces and one known force. That's why I choose to analyze joint C. So FBC, there is a force which makes an angle of 30 degree with the x-axis. So first of all I want to resolve this force into its x component and y component, horizontal component and vertical component. So FBC cos 30 degree is horizontal component, FBC sin 30 degree is vertical component. This is another force which is FCD on horizontal axis, and this is another force which is W, which is mass at vertical axis. So first of all I want to uh, take equation of summation of all forces in y direction equal to 0, or summation of all vertical forces equal to 0, because in vertical forces there is only one known force and one unknown force, so we can easily find out an unknown force. So FBC, which is this FBC sin 30, FBC sin 30 minus W. Now, the force directed downward will taken is minus, so minus W equal to 0. So FBC equal to W divided by sin 30 degree. So if you calculate 1 divided by sin 30, it will come 2 into W. So the answer comes with the positive sign. It means that our assumption was right. At first I was assumed that these all forces are in tension, so this is in tension. This positive sign means that my assumption was right, it is in tension. Okay, so the another equation of equilibrium is summation of all horizontal forces equal to 0. So the force directed toward right is positive, taken as positive. Let's say the force directed toward left is taken as negative. So there is two forces horizontally. One is FCD and the other is the component of FBC. FBC cos 30 degree. So minus FCD, because it is directed toward left. So minus FCD minus FBC cos 30 degree equal to 0. FCD equal to FBC, because FBC is noun to us. That's why I move it to the right side. So FBC cos 30 degree. So FCD negative FBC is equal to 2W. So it is 2W cos 30 degree. If you calculate 2 into cos 30 degree, it will come 1.732 W, which is this W. So the negative sign show that my assumption was wrong. This force in member CD is compressor force. Okay. Now I want to take joint B because it has also two unknown forces and one is known force, which is F, which is FBC. Okay. So FBC is, this force is known to us. So I want to first of all I assume that these all forces are in tension, and then I resolve this force into its component FBC cos 30 degree and FBC sin 30 degree. When the member angle makes an angle with the horizontal axis, then you put cos theta with the horizontal component, and you put sin theta with the vertical component. Okay. If the angle makes with a vertical axis, then you put sin theta with the horizontal component and cos theta with the vertical component. You should remember that. Okay. So first equation of equilibrium equation, summation of all horizontal forces equal to 0. The force directed toward right is taken as positive, and let's say the force directed toward left is taken as negative. So negative FAB, which is negative FAB, which is this. The force this force is directed toward left. That's why I put with it is negative. So plus FBC cos 30 degree. FBC cos 30 degree equal to 0. FBC equal to FAB equal to FBC is equal to, we find out earlier, FBC, which is 2W. So at the place of FBC I put 2W cos 30. So if you multiply 2 into cos 30, you will get answer of 1.3732 W. This positive sign show that my assumption was right. It is in tension. So the another equation of equilibrium is F summation of all forces in y direction or vertical forces equal to 0. So the vertical force is this one the component of this force, and one there is only these two forces. Okay. So FBD, which is this force FBD, negative FBD, negative FBC, which is this force FBC, FBD, negative FBC, sin 30 degree equal to 0. So FBD will comes out negative FBC. FBC we find out earlier, so it equal to 2W. So at the place of FBC I put 2W into sin 30. If you multiply 2 into sin 30, you will get answer of 1. So 1W. Negative sign show that my assumption was wrong. Force in member BD is in compressive. Its force is compressive or in compression. Okay. So now I want to take joint D because it also have two forces known and two forces are unknown. So first of all I assume that these all forces are in tension. If I get answer of with a negative sign, that my assumption will be wrong, and it will be in compression. Okay. So first then I want to resolve this into its components. So I resolve it here. So FAD is a resultant force. So FAD cos 30, which makes angle with x-axis, it with the horizontal axis. there will be cos 30, and with the vertical axis there will be sin 30. Okay, FAD. So summation of force, all vertical force is equal to 0. The force directed up is positive, the force directed will down, it will be negative. So FAD, which is up, FBD, sorry, it is FAD. So I take this force FAD sin 30 degree plus FBD, which is FBD. This equal to 0. So FAD equal to FBD, because FBD is known to us. So negative FBD divided by sin 30. So FBD is equal to negative W, and the negative sign is as it is. So divide by sin 30. If you divide 1 sin 30 divide by, so if you calculate 1 divided by sin 30, it will give you 2, answer of 2. So minus into minus, negative into negative will cancel, it will come with positive. So if the force in member AD is 2W, which is in tension, because the answer is come with a positive sign, that's why. So summation of all horizontal forces equal to 0. The one force is horizontal force is this, the another horizontal force is this, and the another horizontal force is component of this force. Okay, FAD, component of FAD. So FDE, which is this force, FDE, negative FDE, plus FDC, which is this force, FDC, and negative FAD cos 30, which is this force, component of this force, FAD cos 30 degree. So FAD cos 30 degree equal to 0. So negative FDE equal to plus AD, FAD cos 30 plus negative FDC. So I know that FAD force in member AD, and I also know that force in member DC. So FDE will equal to, I put at the place of FAD is 2W, and put at the place of FDC is 1.732W. So if you calculate this all with your calculator, so you will get answer of negative 3.46W, 464W. And the negative sign will show that it is in compression. This force is in compression. Now the greatest force in member AD and BC is which is equal to, both are equal to force in member AD and force in member BC is 2W. Okay, so the given data is that these truss members, this whole truss members only support 24 kilonewton of tensile force, and can support 35 kilonewton of compressive force. It means that beyond, if we go beyond the 24 kilonewton, it will come fail. So the maximum limit of this truss members is 24 kilonewton tensile force and 35 kilonewton of compressive force. Okay, so we know we will find that this mass, which is a critical part of this truss, which can support maximum mass. Okay, by equating these two forces. So now we can say that 2W equal to 24, because these two forces, maximum forces, these two maximum forces are tensile forces. Okay, so this is tensile forces. Now I can equate it with the tensile compressive limit. So since the member can support only 24 kilonewton of the tensile force, so these two forces are maximum two forces are tensile, so I can say that 2W equal to 24 kilonewton. So W equal to mg, you studied it earlier, that W equal to mg, m mass into gravity, so 2 mass into gravity equal to 24,000 newton. So mass will equal to 24,000 newton divided by 2 into 9.81. So mass, the member, these two member can support highest mass of 1223.24 kgs. It can support only this force and this mass in in tensile forces, in tensile. Okay, so uh, now we can find out the greatest mass which in member, which is compressive force. So the greatest compressive force in member is DE, which is a 3.464 W. So the limit of the member which can support only 35 kilonewton of compressive force. So I can say that 3.464 W equal to 35 kilonewton. So this force in member DE support, and force in member DE is 35 kilonewton. Okay, so you can also say that force in member DE is 35 kilonewton and force in member AD and BC is 24 kilonewton. So which is the greatest force? Greatest force is that. Okay, so if how much mass support this member, it will be the highest mass. Okay, so you can for W equal to mg, mass into gravity, so it is equal to 35,000 newton. So mass will equal to 35,000 divided by 3.464 and multiply by 9.81. So mass will equal to 1029.6 kg. So we can say that the critical part of this truss is DE, which can support mass of 29 uh, uh, 1029.96 kgs. You can also say that 1030 kgs. Okay, so the critical part is force in member DE, which can support 35 kilonewton of compressive force. Okay, thank you very much.